This is lesson 32. We're talking about probability. Okay, probability is the number of favorable outcomes over the number of possible outcomes. So let's say I want to know the probability of rolling a 6 on a die. Well, the number of favorable outcomes, let's look at the number of, first of all, let's look at the number of possible outcomes. When I roll a die, I can roll a 1, a 2, a 3, a 4, a 5, or a 6. Okay? Well, out of those, the favorable outcomes are the only way I can roll a 6. There's only one way I can roll a 6. So the probability is 1 out of, and then how many total outcomes are there? Well, I can roll a 1, a 2, a 3, a 4, a 5, or a 6. So there's 1, 2, 3, 4, 5, 6 total ways that the die could end up. So 1 out of 6 is the probability. Okay, and we need to know theoretical versus experimental probability. Theoretical is what should happen. Meaning, if I roll a die 6 times, I should only get heads once with the probability. Or sorry, if I roll a die 6 times, I should only get a 6 once, judging by the probability here. Because I should get a 6 once, I should get a 5 once, I should get a 4 once, a 3 once, a 2 once, and a 1 once. Because they're all equally probable. So theoretical is what should happen if I actually rolled a die 6 times. Experimental probability. Experimental is what actually happens. Let me erase that, sorry. Okay, so experimental probability is what actually happens. Okay, so let's say I roll a die 6 times and I got 3 6s. The experimental probability is 3 out of 6 because I got 6s 3 times out of 6 possible things that could have happened. The theoretical probability is still 1/6. I should only get a 6 one of those times. Okay, theoretically. That's what should happen. Odds. Odds are the number of favorable outcomes compared to the number of unfavorable outcomes. So again, let's look at the odds of rolling a 6. Well, there's one favorable outcome. Then I write a little colon in here. Okay, like those ratios we did. And then the number of unfavorable outcomes. Well, if I'm looking at the odds of rolling a 6, unfavorable outcomes are anything that's not a 6. So that's any of these 1, 2, 3, 4, 5 things. So there's 5 unfavorable outcomes. So the odds of rolling a 6 are 1 to 5. 1 favorable thing that can happen to 5 unfavorable things. Okay, and again, that's how we read this. We say the odds are 1 to 5. So the probability of rolling a 6 is 1 out of 6. So once out of every 6 rolls, I should get a 6. And the odds of rolling a 6 are 1 to 5. Okay? And again, know the difference between theoretical and experimental probability. Alright, let's go on to the next slide. Alright, another thing we need to know is sample space. Sample space is the collection of all possible outcomes for an event. So everything that could possibly happen. So it says to find the sample space of flipping a coin twice. Well, if I flip a coin twice, then I could get heads the first time, and I could get heads again the second time. I could get heads the first time, and then instead of getting heads the second time, I could get tails. I could get tails the first time, and then get heads the second time, or I could get tails both times. So this right here is the sample space of flipping a coin twice. That's all the possible things that can happen. Okay, so there are 1, 2, 3, 4 different things that can happen if I flip a coin twice. I can either get heads both times, I can get heads first and then tails, I could get tails first and then heads, or I could get tails both times. Alright, so this example says a coin is flipped twice and lands on heads twice. So both times it was flipped, it landed on heads. I want to know what's the experimental probability of the coin landing on heads both times, and the theoretical probability. So again, the experimental probability is what actually happened. Okay, so the number of favorable outcomes is, now we're doing experimental here, okay, so the favorable outcomes are landing on heads, and that's over the total things that happen. Well, experimental means what actually happened. Well, I flipped the coin twice and it landed on heads twice. So I got heads twice. And the total things that were happened, I flipped the coin twice. So 2 out of 2 times it landed on heads. So the experimental probability reduces to 1. Now theoretically means what should happen. Again, the heads over the total possible things that can happen. Well, what's the theoretical probability of the coin landing on heads both times? Well, look at our sample space up here. There was only one way that we landed on heads twice. Out of how many possible things could happen? Well, 4 possible things could happen this time. So the probability, theoretical probability, is 1/4. So experimental probability and theoretical probability can be completely different, because experimental is what's actually happened. We got heads both times out of 2 flips. Okay, and then here we had, for theoretical, we had 1 heads out of 4 possible things that could have happened. Okay, so that's the difference between experimental and theoretical. Alright, let's keep moving on. So our first objective is to calculate the probability of an event. Okay, so example 1. The spinner shown at right is spun once. What is the probability that the spinner will stop? And then we got 3 different questions. In sector A, in sector A or B, and in sector A, B, C, or D. Okay? So, let's go ahead and look at these. So we'll do A. Okay. So, again, probability is the number of favorable outcomes, so what we're looking at, over the total number of outcomes. So the favorable outcome here is the number, or the letter A. Okay, that's what we're looking at. We want to know what's the probability it lands in A. So that's the favorable outcome. Over the total outcomes, well, the total outcomes that can happen are A, B, C, or D. Alright, so this is the favorable, what we're looking at. These are all the possible things that can happen. So now I'm going to use numbers to represent these. How many possible ways on this spinner could I get an A? Well, there's only one A. Over. How many ways could I get A, B, C, or D? Well, there's 4 of those. So the probability the spinner stops in sector A is 1/4. Okay, so we got a 1 out of 4 chance. B. We want to know in sector A or B. So my favorable outcomes are landing in A or B. And again, my total outcomes are still A, B, C, and D. Well, how many ways can I land in A or B? There's 2. Over, and then A, B, C, or D, that's 4 possible ways. So I've got 2 out of 4. Which reduces to 1/2. So my probability of landing in A or B is 1/2. That should make sense because that's half of my spinner right there. And then C. What's the probability it lands in sector A, B, C, or D? So my favorable outcomes are any of them. A, B, C, or D. And my total outcomes are A, B, C, or D. Those are the only possible things that can happen. Well, how many different ways can I land in A, B, C, or D? There's 4 of them. And 4 total. And that reduces to just 1. Okay, so the probability is 1. Or we could call it like 100%. It is a 100% probability that I land in one of these 4 spaces. Those are the only 4 spaces I can land in. So I have to land in one of them. So again, that's probability. We've got the number of favorable outcomes. What are we looking at? over the number of total outcomes. And then we reduce if possible. Okay, let's go on to more examples. Okay, and objective 2 is to calculate the odds of an event. Okay, so remember what odds were. Odds are number of favorable outcomes compared to the number of unfavorable outcomes. So again, this is a little colon here. So we're going to write this as a ratio. Okay, remember we talked about 4 ways to write a ratio, and they were we could write as a fraction, or as a decimal, or as a percentage, I believe, or we can write them with this, or sorry, we could write them with the word 2, so like 3 to 4. We could write them as a fraction, we could write them as a decimal, or we can write them with this little colon. So we're going to use the colon to represent odds. So this says if the spinner in example 1 is spun once, just one time, what are the odds the spinner will stop in sector A? Okay, well, what are my favorable outcomes? I'm looking at what's the odds it'll stop in sector A. So my favorable is A. That means my unfavorable outcomes are anything else. That's B, C, or D. Okay? A is not an unfavorable outcome. That's what I want to happen. So when I'm talking about odds, I don't care about the total things. I care about number of favorable compared to number of unfavorable. Well, there's one favorable thing, and there's 3 unfavorable things. So the odds the spinner stops in sector A are 1 to 3. Remember, the probability was 1 out of 4. The number of favorable over the total. Odds are number of favorable compared to unfavorable. So those can be tricky, okay? And there's really no trick to remembering them, so just make sure that you study this up and keep it, try to keep those 2 things straight. All right, let's keep on going.